Let me first introduce myself. My name is Michelangelo Van Dam. People told me I pronounce it wrong. So how do you pronounce it here in Italy? Michelangelo. There you go. All right. Michelangelo Van Dam. In my day work, I work as a PHP consultant. I do a lot of stuff within Europe. So all kinds of crazy things. Always have to do something with unit testing and stuff like that. I'm also president of PHP Benelux. Who has been to Benelux before? To the conference? No? We have an annual conference in January. Good food, good beer, lots of activities. I mean, who doesn't like bumper cars at a conference? No? Okay. Well, yeah, we have those kind of things. So yeah, it's a very interesting place to be. Lots of good talks, but also our socials are always epic. So check it out if you're interested in getting to Belgium. I contribute a lot to open source projects. Most of the time you don't see my work in the code base, but I contribute in the sense that I advise open source projects on unit testing, or I fix bugs and provide unit tests with that. So yeah, there's a whole bunch of things that happen out there. And apparently, for some reason, people like what I have to say, so I speak at a lot of conferences. That's why I'm here. So thank you all for inviting me. And yes, of course, I cannot be here on stage saying, hey, I'm so good, if I don't have any certificates to prove that I can do that. So, but this is enough for me. Let's talk about PHP unit. I know that there are many frameworks out there that provide testing capabilities, but PHP unit seems to be like the most popular one. So anyone in the room not using PHP unit at this point? Be honest. I mean, we don't judge. So everyone is familiar with PHP unit. Awesome. Awesome. So when you're using PHP unit, is it all good? Sort of? I see people. Okay, let's go over some things that you might use running PHP units. First of all, who runs it on the command line? Wow, this is like the majority of the room. Are there people that actually use the IDE play button? Okay, 2, 3, 4, 5, 6, 7. Are there people that are not running the test locally but have a dedicated test server for that? And I'm not talking about CI yet. Yes, 1, 2, 3, 4. Okay. And then, of course, with CI, you have like automated testing executed by Jenkins or TeamCity, Bamboo, or whatever kind of tool. Yeah? Oh, look at that. Half about the room. Then a couple, like 5, 6 years ago, something came along called Vagrant, and Vagrant was like, oh, this is the best next thing, because now you can virtualize, automatically provision it with any kind of provisioning tool like Puppet, Chef, Ansible, whatever, and automatically it spins up all your virtual machines that you need for running your applications. And yeah, so we tried that, and well, we actually have our unit test executed on Vagrant. So it spins up a Vagrant box, runs the unit test, reports back, and then shuts down the Vagrant box. Who does that? Okay, I'm the only one, or we're okay. Yeah, we're brothers, right? It was not really what we were looking for, because the time it actually required to spin up a virtual machine, have it provisioned, and then executing our unit test, that was like, okay, start unit testing, let's go for pizzas. So it wasn't really working that way. And then all of a sudden, people said, well, Vagrant, that's old school. Let's go for Docker. And I was like, yeah, well, what's Docker going to be different than Vagrant? I mean, it's virtualization, right? Well, not entirely. But we get back to that. But anyone using Docker by now? Yeah. Like that's half the room. Awesome. So we're pretty good there. Running your unit test, no matter what kind of platform that you use, also has a lot of drawbacks. One of the main one, it takes really long time to run all your tests. Is there someone in the room that has over 10K of tests? Yes? Yeah, don't be shy. Be proud of it. Okay. So I don't need to continue who has more than 100K. Okay. All right. So you're on 10K. 5K maybe? 5K, all right. 1K? All right. We're still not there. 500? Who offers less? No, okay. So yeah, if you're under 500 unit tests, that will take you 1 second, 2 seconds, maybe. Yeah. So you're not really going to see a lot of improvement there. The moment that you ramp up like 10K, 50K, 100K, this is where you start seeing, oh, this is going to take a long time. And when you execute your unit test, your environment is not always ready to execute those tests at that particular time. I'm a consultant, so I get with clients and we work on a feature. That's why they hired me. And then all of a sudden, someone enters the room like, oh, it's broken, we need to fix this. So all of a sudden, we need to switch our environment and start working on that fix, because we actually need to fix it right away, because otherwise they lose money. And we run our unit test. And most of the time what I see is, oh, but we still have code changes made from our feature that we work on, and now the hotfix is actually screwing things up. So we end up with mixed environments, mixed code, and things break, especially when we run a unit test. Who's been there? Okay, yeah. If you're not, okay, you're lucky, trust me. And also, when you run your test, it doesn't provide like good feedback. I mean, nowadays everyone is using CI, continuous integration, and you get like, okay, everything is okay. You get a green ball, and then something breaks, and then you get a red ball, and then if you're lucky, you have like flashing lights and alarm systems going off. But most of the time, it's just more like you have a dashboard somewhere, and as a developer, you need to look around the corner to actually see it, so you don't actually see, oh, something is broken immediately. So that is not really the way that you want to continue. I came across this XKCD image, and this basically, emphasizes on what developers are dealing with on a daily basis. So you're working on code bases, then you need to test this before you push it up, and then you have to wait. You're lucky because you don't have that many tests, so 1-2 seconds, that's okay. But with 10K tests, that can lead up to like 5 minutes or 20 minutes. You don't want to wait that long because you want to continue doing your development, right? That is what you would like to do. You don't want to wait. You want to do stuff. So, yeah. These are the challenges that you come across when you're dealing with unit testing. Another thing I came across, system failures. And one of the main reasons why I actually got this talk started was I ran my unit test, and then all of a sudden I got memory exhausted. You know, the fatal error, memory, try to allocate this much memory. Yeah, that was not really working for me. So every time I was like, okay, we're having these massive unit tests, and then my laptop says, yeah, well, you don't have the memory. So we need to figure out a way to do stuff. And then another thing that happened was, because I ran all these tests, I was also running all these systems, integrations, and because these system integrations also produce logs and all kinds of artifacts, all of a sudden my disk was full. I was like, hey, wait a minute, this is not supposed to happen. So how can we solve this? Another thing is that especially when you're working in a environment that is not really IT related, the Wi-Fi is most of the time just a homegrown kind of thing that they put somewhere in a corner of the office, and then all of a sudden the network just drops and you don't have the network. And especially when you run also integration tests, when you connect to systems, yeah, that is troublesome. Um, so yeah, that wasn't really good. And last but not least, especially if you are dealing with a very complex subject, you're running your unit test and your unit tests are still indicating something is wrong, and you try this, you try that, and you keep on running those unit tests. All of a sudden your computer says, I'm sorry, I'm done. Crash. Everything is blocked. You can no longer work with your system. So all these problems were piling up, and I needed to come with a solution for that. So people were talking about Docker, and I said, oh wow, if everyone is so enthusiastic about this, let's have a look what Docker is. And in my opinion, Docker is a technology platform. It's not like virtualization, it's more like a technology. It runs processes in separate containers, which is like a separate memory space adhering to kernel environments. I'm not a system engineer, so I have no clue how to technically specify it, but this is how I interpret it. It scales fast and seamlessly. That is the marketing term that they use at Docker Swarm. And the containers are easy shippable. So if you put something in a container, I can pass it on to you, and everyone has the same thing. That is the promise. So everyone I was talking to said, oh, really, it is the best next thing since sliced bread. When everyone says that, I'm very skeptical about this. So I started investigating it first and tried to figure out how is Docker used. And as we talk about containers, containers in the real world means we put stuff in, it gets put on a truck or on a train, it gets brought to the shipyard, it's being put on a ship, out to sail, and on the other side it gets dedocked and so forth. And then you come across, this is something new, trending. I'm not sure if it's also here, but in Belgium, people have this tendency to build houses out of containers. I know. It was not made for that, but people tend to do stuff with things. But in software, when we talk about Docker, I saw three most common use cases for Docker. First of all, mimicking a distributed architecture. We have something on the cloud, and we have all these separate microservices and all these separate systems. So we want to mimic that environment as closely as possible using Docker. So we have 2 web nodes, we have a cluster of databases, we have a cluster of MongoDB, Elasticsearch, all that stuff, and it's all provided in Docker, which is pretty awesome because Docker doesn't require that amount of CPU usage, so you can literally mimic that environment. I tried to do the same with Vagrant, creating all these virtual machines. After 3 virtual machines, my laptop said, well, I'm done. You can do it yourself. So it's a huge improvement. So yeah, that was probably the most common one. Anyone in the room using Docker the same way? There you go. Well, a lot of people still, so only a few people. Then I saw people that said, you know what? We don't build like a distributed architecture. We build a complete application and put it inside a container. And that was awesome, because now I actually had something that was portable over all the systems. So I put it in a container, let's say a simple financial package. Up, there you go. Deliver to you. You have the same thing. Deliver to you, same thing. So that was also a pretty good opportunity. And then the third one, running for single purposes. Basically, going to Starbucks, getting a paper cup, fill it with coffee, drink it, toss the cup away. And that was one of the approaches that I saw only a few people use. But that got me very interesting, because that is exactly what I'm doing with my unit test as well. I run my unit test. When it's done, I don't need it anymore, so I can throw it away. So it was the third one that actually got me thinking about, how can I do this? So I ended up speaking for the first time in late September in Münster in Germany with a user group, and we were having a discussion about, okay, we have all these unit tests, and you know, Germans, they like everything to be very high quality, so they have like massive unit tests, and it takes really a long time to execute. And so we started working with the user group, and yeah, we came up with a way to solve our problems. So this is me at that user group, and we were running the unit test right there on the spot. So how do we get to the point where we actually can speed up our unit test? Well, first we need to know where we are at this point. And the most common thing is run them all. That's the best benchmark you can have. You run all your unit tests in one go. So let's do that. And as you can see, we have little less than 4 seconds for 10K of tests. Not bad, in my opinion, right? So everyone was like, yeah, but this is only 10K. If you scale it up to like 50K, you probably get like 5 seconds or 10 seconds, and that's too long. People, developers, they want to execute, get a response, and move on. Okay, let's see, how can we split things up? I mean, if we can separate things, maybe we can find ways to actually execute them more efficiently. So we were looking at, okay, can we divide on directories? Can we divide on class areas or anything? And we decided we're using the add group annotation. Once you have add group annotation in your code base, you can have like separation based on functionality and ordering of your test. So we looked at, okay, what kind of groups do we have? And in those 10Ks, we have an entity, we have filters, we have a flight manager, and default if you haven't specified any other group. So the majority is also in the default group. So how can you actually execute those? Well, you can actually say minus minus group, and you provide the group name, and it will only execute that particular group. Well, this makes a lot of sense. So let's see if we can loop through all the groups and execute them in that way. So basically running PHP unit, all of the unit tests, but separated on groups. Let's have a look here. This is the command. I'm just using bash for this purpose. And when I run it, it takes a little while, because first of all, PHP unit needs to go through all the groups of your unit test, and then it starts executing it. So as you can see, it's already a little bit slower, 10 seconds already. And then the rest is almost a second. So taking this into account, this is 13, 14 seconds. We were less than 4 seconds. So this is not really improving. Is there a way that we can actually speed it up? And this is where we actually decided maybe Docker can help us. Okay, so how do we actually execute PHP unit using Docker? Well, we just use the basic PHP CLI image from the Docker Hub, and we execute PHP unit in it. So let's run it. And this is all the tests all at once. 4.6 seconds for everything. So it's a little bit slower than when we run it natively. I wasn't really feeling assured at this moment. I was terrified that Docker is not going to be the solution that I was looking for. But I don't like to give up that easily, so I started further investigation. And one of the things is we had groups, so we can split up our unit tests using groups. What if we execute them in parallel using Docker? Would that speed things up? So how can you split up things on your command line? Because PHP is non-threaded, so how can you actually make it threadable? We came across GNU Parallel. I'm not sure if you're familiar with it. It's an open source project that actually allows you to execute things in parallel. That's the bottom line. And one of the nice things is it's command line, so we can completely script it, of course. And one of the things was, how do we provide the parameters that we actually sent into our command line string? So this is where we actually grab our group, and then we pipe it to parallel. And how we get our parameters in? Well, we use those braces actually to do the replacement. The slides will be online, so if you want to catch up, there's no problem there. So now we have split it up our execution in parallel using group annotation, running in the this is still on the command line. So no, this is using Docker. So let's see how this works. So we push everything into Docker. And as you can see, it's already slowing down, because now this is 2 seconds, 2 seconds. So now we're at 18 seconds. And we started with it less than 4 seconds. Why is this so slow? It should execute faster. So we started digging in it. And one of the main problems was, because we execute Docker as verbose in our command line, that was slowing things down, because now Docker had to communicate back into our console, so to speak. So how can we solve this problem? Well, let's push it to the background. And because I could not see what's happening, I'm using time now in order to figure out, okay, what is going on. So let's execute this and see what happens. Come on. And now, bam, 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 everything is executed. And then people say, oh, look, this is like 26 microseconds. No, it's not. Yeah. Okay, all right. So this is the total execution of executing this. But there's one catch. You push everything in the background, means that the total execution time will be finished when the background processes are finished. And that is the 2.6 seconds. So now we're from almost 4 seconds to 2.6 seconds. This is where we actually get the gain. But we're not there yet, because there's also one huge problem. Anyone in the room who wants to? Right! Where are my failures? The reason why I say where are my failures is, as long as everything is okay, do you need to know that what's okay? No. If it's okay, you don't need to know. You need to know when something breaks, right? So how can we capture those failures? again, we needed to look at what Docker had to offer. And this is really, really the magic that I tried to figure out, and I was so glad that I actually had this done, and it was along with the people from Barcelona that actually helped me figure this thing out. So what you will see here is maybe, yeah, you can take a picture of this. Yeah, they're taking pictures. You got it? Yeah? Okay. Uh, let me make this more clear in layman terms. So what we do in this command is we loop over our at group list. We run these in Docker, demonized. Again, we loop over the group list because we need to capture everything at the end and fetch the exit status of PHP unit from the containers. And if the exit status is different from 0, show us the failure. And when we execute this, so I intentionally broke something, in 2.8 seconds, everything is executed and you get your failure right there. And now you can completely automate this into whatever kind of environment you have. But the nice thing is, you as a developer can run this on your system. You can, I mean, this is a batch script, so you can actually script this and have it execute on your IDE, on command line, whatever you fancy doing. And now you can actually parallelize your unit tests, run them in Docker, and it only reports if something is broken. Speeding up all your unit tests means that you as a developer will not commit any faulty code into the repository. Yeah? I mean, it is a, if I go back to this one, it's a lot of execution right there. But if you script this, and you script this well, it really is super fast. And then, okay, we're still not at the 10K level yet, but if you ever get to that point, you will be thankful that you have this. And one of the nice thing is, I showed this with PHP unit. For me, it solved my problems for PHP unit. But try to imagine all the other things that you have in your daily life, in your daily work, that takes a long time to execute. Use it with Docker, use it with Parallel, and all of a sudden you can speed things up. So, and I'm not sure if you guys are familiar with Docker in that sense, that the images that you grab from the system, well, they allow you to actually test all versions of PHP, which gives you also the ability to say, hey, you know what, we have this feature, but everything, all our unit tests are running perfectly. Will it also run on the next version of PHP? You can test this, you can check it out, and you can say, okay, we're now compliant with all these versions. This is also what we did with WordPress to make sure that any of the plugins that we have was actually running on all the versions of PHP that we currently have on our systems. And now you can actually do whatever you want to do in parallelization using Docker and throw away after you're done. For me, that's for the win. That's a party. This is really awesome. Right? So I know this talk is about 30 minutes. So now let's fill up the other 30 minutes by answering questions. Yes.
I don't know if you tried about it. I don't know if it could be a solution that is more more quick, more efficient instead of your. But instead of trying to get the logs the logs of your container,
Hmm.
did you try to put the logs on a mounted volume?
Yes, we tried that. If I can show you here, right here. I think it's this one. As you can see, we have the logs of the unit test already stored, so that was on a mounted volume. But the problem is the moment that you have a mounted volume, you're also creating more latency because it needs to interact with the host system. What we figured out was if we have the output of PHP unit, because PHP unit is a nasty program, it always outputs when you execute. You cannot force it to go into error. You cannot force it to go into a file. It always goes back to the standard out. That is the behavior of PHP unit. So you always have that output. By putting it in a container, demonize the container, the output will still be generated, but it will not be attached to a TTY. So the execution is faster. And because we already have that output, we don't need to write it to file, we don't need to read it from file. So looping back onto the system and say, okay, give us the Docker logs, which will display whatever is being outputted, gives us immediately the feedback. So the result was faster than writing it into a log file and then read from the log file again. So
Okay, thank you. I was curious because it could be another solution in order to use maybe other services that could read from those mounted volumes. So
yeah,
it's something that you don't use by yourself.
no, it's well, this is what I want to have developers on their own system. And this is before it goes into the repository, before it goes into CI, before it actually ends up in some environment. With this, we can actually make a pre-commit hook that actually runs this automatically the moment the developers want to commit, which is even more awesome because now the developers are not afraid to run their unit test because it's not taking that much time. It's just as quick as just committing to a repository. And better, when you commit, the commit has to be detected by the CI. CI then needs to queue it, then execute it, and then return the feedback loop, which is adding additional latency on the whole process. So by putting this immediately on the developer machine, the developers get faster feedback, and faster feedback is what unit testing is all about. You want to break fast at the moment something is broken. Yes?
Thank you.
Okay. Any other questions? Come on. We got plenty of time to fill.
I didn't get why did you need to use parallel. Cioè the real reason you have to use parallel.
Okay. So the question is, why do we use parallel? Well, parallel is basically the tool that allowed us to actually execute PHP unit next to each other. So we can actually split up PHP unit using group annotation and have them execute next to each other instead of after each other. And that's the whole purpose of parallels. With parallel, because PHP is non-threaded, so you don't have threads. It's not something that you can split up. So the biggest challenge that you have is if you have that many tests, not all the tests need to wait until the other test has finished. So whatever you do, try to execute as much as possible simultaneously. But with PHP unit itself, you could not do that. You can separate on directories, you can separate on this, and then execute PHP unit only on those elements, and then try to execute them all at the same time. But on your local machine, and most of the developers that I come across, they work on either Linux or they work on a Mac, that didn't allow them to actually execute things in parallel. Using a tool like Parallel allowed us to do this on the command line. So if you look at this command line, this is one command line that actually allows us to execute things not in sequence but in parallel.
Okay, but any container running is a separate.
Sorry, is a?
Each of the running container is a separate process already.
Yes.
So they can run in parallel, just using bash available or tools.
Yes, I know, but if I go back to...
So why using parallel?
Okay, to answer that question, where is it? Okay, so over here, I'm splitting up on the groups. I'm using my Docker, and I'm not using any parallels, right? Oh yeah, it's using parallels, sorry. Okay, so I probably need to add one more slide in between that actually uses the group annotation and pushes it into Docker. But it's the same thing. When you execute this, it will execute this inside a Docker container at a sequence, because you're executing outside of Docker, saying, okay, this is my group, and I will feed it into your Docker system. And the only way that you can actually say, now execute all these Docker containers simultaneously, if you execute a command in parallel and not just on the command line. So I understand what you're saying, and good point. I will add it to my slide that you can actually see if I run the split up of my unit test based on group or directory and then execute it into my containers using Docker, it will still be executed after each other and not in sequence of each other. Even if I push it as a demonized container, it will still execute one after each other.
Okay.
Yeah?
Quite clear.
Okay.
Can you tell us what happens if you depend on shared resources? Like, say you have a Symfony project, which uses, when you test, it spins up like the test database on the file system. What happens if you parallelize these tests, which use the same file?
It all depends on, because now we're talking about integration test and not unit testing, right? What happens with integration tests, you need to have like complete independence on resources. So if you are using a database or a file or whatever that is being used by multiple tests, then either your tests are not written correctly, or you need to make sure that you have a fixture that you can clone towards all those tests.
All right, so you would just use. Like
you can use the same basis, but clone it for every, and don't create dependencies in your test.
Yeah, right.
There is the annotation at depends, so you can actually say you can only execute this after the execution of the previous test, but that is not really good testing practices.
Thank you.
So create like non-dependency on a single resource. Any other questions? Oh, here in front.
Hello.
Hi.
I notice in your example you have switched split the groups in parts which are very not equal. There's a very big group and 3 very little groups.
Yes.
I think your strategy bases on making groups of the similar size, because otherwise you have the execution of the bigger group, which gets no benefit because a single execution takes the same time.
Yes.
So do we find ourselves in the position to assign groups to our tests just for the purpose of splitting them into containers, which is kind of outside of the scope of the domain of our code base, and we just define the groups for the sole purpose of splitting them? Is that what you're suggesting?
Yes. the big group that you saw, that was my default. So in that default group, I should take more time and split more up on basis on either functionality or logical coherence. Uh, the add group annotation is more like, okay, this is purely from a logical point of view. So if I'm dealing with orders, all my tests regarding all the ordering systems will have the add order annotation. If I'm doing like interfaces, I have all my tests annotated with the group interfaces and all those kind of things. So it's more about logical grouping of your test cases. This was like, okay, I needed something quickly, and let's work on this. But yeah,
we get the most benefit if we can make groups of the similar
Yeah.
size and similar execution time.
Yes. In this case, I used the group to split all my tests up, but you can also do this based on directories. So you can create like test suites based on functionality or modules or bundles or whatever tooling that you're using. So you can say, okay, only execute these test suites with these parameters, right? And then you can actually adhere to them, saying, okay, we're going to do the ordering, the invoicing, the subscribing, and all that. We group them together and we toss it into the same logic that we present here. I just took add group because that was something more easy.
And one other little thing, in your experience developing on some machines, is there a limit of parallelized tasks that you think should not be crossed because it goes
Well,
maybe it makes your machine crash?
well, if you have a code base and you have so many group differentiations, we try to limit underneath 100, and that still works okay. I haven't seen anything that goes beyond 250. So
No, I was thinking a lot less. 100 is a lot.
no, I can run 100 in parallel on my machine. Okay, it sounds like he's about to lift off, but it still does it. So
No, that's awesome. I thought a lot less than 100.
well, the nice thing about, especially with the pure unit tests with PHP unit, they're very lightweight, very low memory consumption, and yeah, they're really fast. So if you parallelize this with like 100 or 200, it should not have that much of an impact on your system. It's only your CPU tries to catch up on processing all the information, and that's why you have like, okay, it's about to lift off, but memory usage is still low, and you can still operate your computer, so there's no real problem there.
Thanks a lot.
Yeah.
Hi.
Hi.
Have you ever tried to use the PHP unit test listener to handle the logs to reduce the output somehow? So maybe
Yeah.
pass out the output on the console and try to use, I don't know, maybe just the output for failures on the listener.
We use the PHP unit listeners on our CI system because it has more value over there than on our local environments. Because as a developer, I just want to know if I broke something. So the PHP unit listeners.
I was thinking about trying to shave off a few more performance from that, maybe, because the JUnit log is pretty verbose.
Well,
so
it is an interesting concept because it basically is asynchronous processing. So the listener sees, oh, something has broken, and then calls a callback. So yeah, you can actually process this in a more efficient way. But that's the same thing that Docker does also. So Docker does the same thing. The only thing that you need to do is add Docker wait, because you need to make sure that your execution has completed. That's the only thing that stops the processing. And in my example, you can also say, I'm running PHP unit in parallel. I can also execute the wait and log functionality of Docker also in parallel, which I haven't done in this particular example.
do you think also that you can leverage this same approach on functional testing, where the execution of single test is much longer, or you think that you should use something
On
different?
function, well, with PHP unit or with this concept, you can actually go for conceptual testing, end-to-end testing, acceptance testing, but be very careful because you're probably will need to scale up also the environments that you're actually executing your acceptance. Otherwise, you have the same problem as we discussed earlier.
I have a solution of my own, but I want to just
Yeah.
see for this solution
Yeah.
how this could work.
Uh,
Currently, I use I wrote a library to run the tests in parallel,
mhm.
and it doesn't scale well for unit tests because I run a single process for each test file. So
Okay.
the PHP unit boot up is too much of a overhead.
Yeah.
But for functional testing, it works pretty well because each test takes 1-2 seconds, so
Yeah.
the overhead is negligible in that case.
This is also very good for behavior testing, so behavior testing, because the biggest problem I see with behavior is it's so slow. Now you can actually speed things up, especially if you have a lot of these behavior tests. I wouldn't suggest to use this for stress testing. I mean, stress testing is already putting your system under a lot of stress, and if you do this in parallel, you're basically DDoSing your system. And I'm talking about experience. No, seriously. So there's a lot of things that you can do with this, especially from a testing point of view, also from processing, file uploads, media conversions. I mean, I just opened up a box of Pandora of all new ideas, you know. This is what I use for speeding up my unit test. Anything that you can come up with that's taking way too long, like more than 5 seconds, means you can actually run it in parallel and push it into Docker and execute it. So you should be very okay with that. The reason why I love this approach is, as a developer, I don't want to poison or make my code base dirty before I commit. I want to make sure that what I commit is fully tested, doesn't break anything, gets pushed into the repository, and then CI takes care of everything else. And if I can prevent stuff from breaking, then CI doesn't need to report something was broken. And that's more like an honor kind of thing rather than this is good practice. So, yeah. Any other questions? No? Well, I hope this was interesting. I mean, I had a lot of fun trying to explore this, and I hope you guys have a lot of fun, trying this yourself. Let me also know how it worked out for you, because I really want to have that feedback. The feedback that I got already is tremendously awesome. So everyone is really enjoying this. So if you guys enjoy this, let me know. If it doesn't work for you, let me know as well, because maybe we can reach out and try to solve it, how we can make it better for you. All right? Thank you very much. Enjoy the conference. Awesome.